In this lesson, we're going to carry on with the script we started making in the previous lesson where we created our walking variables, and now we're going to utilize those variables to create the movement functionality for our character. Let's get started. So at this point, we've already established to move this character, we will need to apply force to a rigid body component on our character to move him around. So how do we do this? So first, to gain access to those components on our character, we're going to need to apply this script onto our character. And remember, we created our WrapTuck character here, which contains our rigid body 2D and our box collider. So all his movement was going to be happening on this main object here. And remember, the sprite is only for animation. So let's click on our WrapTuck character and let's drag this movement script onto it. So as you can see, remember we created walking speed as a public variable. So now I can just click and drag this and change the value. Our facing direction forward is true. That's the checkbox that you see there. And we can visually see that as we're testing. So that's why those are public. So now to open this script, let's get in and carry on. Let's double click this character movement script here. And this is exactly where we picked off, where we left off before. So now where do we want to apply the force in this script? And if you look, we have void start. So as soon as the game starts, do we want to apply force? No. So we do not want to put it in there. Let's close that off. And actually, we don't even need this start function in our script at all at this point. So I'm just going to highlight that and delete that. That function is useless for this, what we're trying to do here. So void update. Every frame, do we want to be able to detect if we can move our character? Yes, that sounds pretty good to me. But one tip, as we are affecting and applying force to a rigid body, that's a physics-based component. So one little trick here is there's a function called fixed update. Just add the word fixed there. And what that does is it doesn't calculate your force being applied every rendered frame of your game. It calculates force every physics-based frame of your game, which is exactly what we're doing. So pretty much a good thing to note is anytime you're applying force via a rigid body, you want to use the fixed update function. Alright, so now we know that we're going to be using the fixed update. I'm going to type the line of code that's going to let us apply force in the x-axis to move our character, and then I'll break it down from there. So first we want to go rigid body 2D dot velocity, and that's going to equal a new vector 2, and I'm just going to leave these brackets here. Let's just say x and y. Alright, so what is this? Okay, so let's break down this line very quickly here. So first, to apply force to our rigid body, we need to access the rigid body. And as we apply this script to an object that contains it, all we need to do is type in rigid body 2D. It's going to look at this object's components and say, oh, we have a rigid body 2D. Now what do we want to access? Dot velocity. We want to access the velocity and pass off some information to there. So now what is a vector 2? Anytime you want to get or set some transform or any values to apply to an object's x or y value, you want to use vector. A vector will hold positional information. So whenever you create a new vector 2, it's going to always come with x and y values to pass off to. So you can use a vector 3 if you want to put some in the z-axis as well, but this is a rigid body 2D, so we only have x and y values to pass off. And one thing I wanted to show you is when I put the open bracket, you'll see vector 2, and now it's telling me right in here, it's a nice hint. It says the first value you put in is a float value for the x-axis, separate it by a comma, and then you have your float y-axis in there as well. So now we know what we can type in here. So what do we want to pass off in the x-axis? That's going to be our walk speed variable. So let's go walk speed. And this is called IntelliSense. It opens up a box that when you start typing something, it's going to give you a list of options that is kind of spelt the same as what you have started that's applicable in this case. And the reason why, you can see this is a float x, and we created this variable as a float. And we're going to use this value for our x-axis. So in our x value for velocity, let's add 10. Hit that, walk speed, sure. Comma, we are not actually adding any velocity to our y value. We are not wanting him to walk up and down. That wouldn't make any sense. So let's just keep the value that's there right now, which is always going to be 0. So let's go rigid body, body 2D, and we want to go dot velocity and dot y. And because we just made a whole new line of statement, we're going to end it with a semicolon. That means that's the end of the sentence, that's the end of the function. And what you see, I don't know why it gave me a capital rigid body. I want that lowercase. And why do I want it lowercase? Is because this rigid body is applied to the game object that we are currently typing the script on, which means it just tells to look on the local object when it's all lowercase. If it was uppercase, it would be looking all over your game and just kind of be a little bit messed up. So I'm going to keep it there. So what can we do here? Let's make a comment to remind ourselves what this is. So this line of code is applying our walking velocity to move our character. All right, so we've accessed the rigid body, accessed the velocity component, created a vector 2 to store the x and the y values of velocity to add, and applied our walk speed variable to move our character in the x-axis by whatever value we have here. So we are all good. There is our first line of code to use our variables to move our character. I'm going to save it. Now let's take a look and see what this is doing to our character. All right, this is going to be pretty interesting. So let's go back into Unity. I'm just going to close this off. And now we have that script applied to our character. And let's hit play and see what happens here. He should be moving in the x-axis, right? Hit play. Whoa, look at this. He's just sliding all over. So what we can do now is we're in our playtesting mode. So he's stuck on that boundary right now. So let's move this in the negative. And now he's going to be moving backwards. So now we're just playing with the amount of force that's being applied to our character. Look at him go. It's pretty fun. So as you can see, we have a few more things to do here. What we need to do is we need to make it so whatever, we don't want it to be constantly at 10. Right? Or else he's just going to be sliding like a crazy man. And we want to be able to control that with our keyboard, which direction he's going to be moving in. Right? So let's get out of here. Because we're in play mode, that value goes back to what it was beforehand. And let's go back into our script and let's see how we can use our input to select the direction we want to move our character in. All right, this is going great so far. So let's carry on. What we need to do now is we're gonna utilize this move direction variable, and remember we didn't apply anything to it because right now we're gonna see how we can apply a value to it based off of the input that we're typing on our keyboard. Remember we adjusted this update function to be a fixed update. We're gonna need an update function to constantly be checking every frame of our game which input we're pressing on our keyboard. We don't want to wait if he's affected by physics then and you're pressing this key, right? That wouldn't make sense, or else your buttons just won't work. So let's create a void, just an update, capital U, has to be exactly the same. Every function has open close brackets at the end of it. And let's create our open curly, close curly brackets. Let's take that move direction variable and make it do something now, okay? So let's type in move direction, and to assign a value to a variable, all you need to do is hit equals. And now whatever we type after this is going to be applied to this variable. So now, what do we want to be applied to this variable? We want to get the direction of our input that we're pressing on the keyboard. So there's a very commonly used function, and that's called input. Input, all right, so there's the base of it. And then what do we want to get from our input? Let's hit dot, and let's go get axis. And you can look at the Unity scripting reference for more information on this if you wish. And which axis do we want to get? We want to get our horizontal, that's not how you spell it, horizontal axis. All right, and because this is the end of a statement, semicolon that one there. All right, so let's take a quick peek at what this is doing here. So based off our input, whatever we press on our keyboard, we want to receive the axis that we're pressing, and that's going to be the horizontal axis. Now this horizontal axis is orange and has quotation marks because this is a string-based variable. And that means it's a variable that has a title based off of characters, a string of characters. So anytime you're defining a string variable, you always use the quotation marks. Now, where do we get this variable from, and what defines what the axis is? Unity has built-in get axis components. So if you go to edit, and then we go down to, oops, not in MonoDevelop, we want to go back to Unity, and let's go to edit, project settings, input. So now, what do we have here? Look at this, our axes, and here's our horizontal. As you can see, it's a string titled horizontal, capital H, and now that's the name, horizontal. Negative button is left, positive button is right, or you can do A and D, all that kind of stuff. So basically what we have here is when we pressed our left arrow key, it's gonna result in a -1. It's gonna feed us back the value of -1. And when you hit the positive button, it's gonna feed us the value of +1. All right, so let's go back to our Unity script now that we've seen our input. So now that we know the values that we're getting from our horizontal axis and what buttons and how to see what's going on there, let's plug this variable in. Let's utilize it to create some simple math to tell which direction we want our character to move in. So walk speed is currently constantly moving in whatever force our variable is, which is 10. I want it to be nothing until I hit something, right? So our walk speed, let's use some math here. Let's go, it's going to be move direction. Oops, I need my capital in there. Multiplied by walking speed. Perfect. Let's hit save. So what is this doing here? So now we have our move direction times walking speed. Our walking speed is 10. It can be any number really, but move direction is always 0 until you hit something, right? So anytime you multiply 0 by any number, it's going to be always 0. So when we hit the left key, it's going to be a -1. Anytime you multiply any number by a negative, it's going to be a negative, whatever the force is here, right? And because it's 1, it's going to be -10. And when we hit our right key, it's going to be a +1. Well, 1 times whatever our walking speed is going to be our walking speed in the correct direction. So now let's take a look and see how this is working. Let's go back into Unity, hit play. All right, so let's make this nice and clear for you. WrapTuck character. Okay, so our walking speed is set to 10 and our move direction is set to 0 right now because we're not pressing anything. I'm going to hit the right arrow key. You're going to see it goes up to 1 and now he's moving. And I'm going to hit the left arrow key. It's in the negative, so it's negative our speed. There we go. We can now move our character around, right? Pretty cool stuff. So now I'm going to hit unplay, if that's something. Open the script back up. For your benefit, I would definitely suggest doing a detailed comment in whatever you want to say here. I'm going to say, I'm taking input to get our direction to move our force in. Sure, you guys can write whatever you wish there. Okay, so we're at a great point now. We have our character walking around back and forth. There's only one issue here. He's kind of moonwalking in the other direction. He's not flipping and facing the other way, right? So we need to move on to the next lesson where we're going to take that forward Boolean variable and we need to make it false when he's moving the other way so we can apply some logic to flip this guy around. Alright, so it's pretty cool. I'm glad we can end the lesson with some nice dynamic movement here. So now let's carry on and let's flip this character around in the next lesson. Alright, I'll see you there.